Welcome to Math with Mr. J. In this video, I'm going to cover how to solve and graph one-step inequalities. We will take a look at addition, subtraction, multiplication, and division inequalities. Everything is time-stamped and put into chapters, so feel free to jump around. We will start with addition and then go from there. Now, when we solve inequalities, we want to isolate the variable, get it by itself on one side of the inequality. We do that by using inverse operations. So this is very similar to when we solve equations. One thing we need to be aware of, though, when it comes to inequalities, remember, we need to flip the inequality symbol, change the direction when multiplying or dividing both sides by a negative. Now, once we solve the inequality, we can graph the solutions, all of the values that make the inequality true. Let's jump into number 1, where we have x plus 12 is greater than 18. So we need to isolate that variable of x. We are adding 12, so we need the inverse operation. The inverse operation of addition is subtraction. So subtract 12 from the left side of the inequality. Whatever we do to one side, we must do to the other in order to keep the inequality balanced. So subtract 12 from the right side as well. Now on the left side, these 12s cancel each other out. So x is now isolated. We have x is greater than, and then on the right side, 18 minus 12 gives us 6. So x is greater than 6. That's our answer. So any value greater than 6 is a solution of this inequality. It will make it true. And now we can graph x is greater than 6. So we're graphing all of the solutions here. And we can start with a number line. And we'll put 6 in the middle. And then a couple of numbers on both sides of 6. So we have 4, 5, 6, 7, 8. Now remember, when it comes to graphing inequalities, a filled circle shows that we are including that number. And then an open circle shows that we are not including that number. So here, x is greater than 6. We are not including 6. 6 is not greater than 6. It's equal to 6. So we're going to start at 6, and we need an open circle. Now we need to represent the greater than 6 part. So we need to draw an arrow pointing to the right, the direction of all of the values greater than 6. So an arrow going right. And that's our graph. So any value greater than 6 is a solution of this inequality. It makes it true. So x can be anything greater than 6. Now, one last thing we can do here is check a solution to make sure we are correct. Now, we can't check every value greater than 6. So what we can do, we can check one value to see if it works. Let's use 7. So plug in 7 for x here. So we have 7 plus 12 is greater than 18. 7 plus 12 gives us 19. 19 is greater than 18, so this does work. We are correct. Our answer for number 1, x is greater than 6. Let's move on to number 2, where we have a plus 9 is less than or equal to negative 3. So we need to undo that addition. The inverse operation is subtraction. So subtract 9 from the left side. That means we need to subtract 9 from the right side as well. As far as the left side, these 9s cancel each other out. So we have a is now isolated, is less than or equal to, and then on the right side, negative 3 minus 9 gives us negative 12. So a is less than or equal to negative 12. And now we are ready to graph this. So start with a number line, and then we'll put negative 12 in the middle, and then a couple of numbers on both sides. So we have negative 14, negative 13, negative 12, negative 11, negative 10. Now, a is less than or equal to negative 12. Negative 12 is a solution. It needs to be included. It makes the inequality true. So let's fill a circle at negative 12 to start. Now we need all of the values less than negative 12. So an arrow going left. And now that inequality is graphed, our solutions are graphed. A can be equal to negative 12 or anything less than negative 12. Let's check a solution by plugging it in for A and see if it works. So we need anything less than or equal to negative 12. Let's use negative 14. So plug in negative 14 for A. Negative 14 plus 9 is less than or equal to negative 3. Negative 14 plus 9 gives us negative 5. Negative 5 is less than or equal to negative 3. So we are correct here. And we're also actually going to check negative 12 as well to make sure that works, since A can be equal to negative 12. And we will do this mentally. So plug in negative 12 for A. Negative 12 plus 9 gives us negative 3, and negative 3 is less than or equal to negative 3. So negative 12 works as well. Our answer, A, is less than or equal to negative 12. So A can be anything less than or equal to negative 12. So there's our addition section. Let's move on to subtraction. So here are our subtraction examples. Let's jump into number 1, where we have g minus 7 is less than or equal to 2. So we need to solve this. We need to isolate that variable of g. Now we are subtracting 7, so we need the inverse operation of subtraction. That's addition. So let's add 7 to the left side of the inequality. Now, whatever we do to one side of an inequality, we must do to the other in order to keep it balanced. So add 7 to the right side as well. Now, as far as the left side, these 7s cancel each other out. G is now isolated. So we have G is less than or equal to, and then on the right side, 2 plus 7 gives us 9. So G is less than or equal to 9. And that's our answer. So any value less than or equal to 9 is a solution of this inequality. It will make the inequality true. Now we need to graph this inequality, all of the solutions. So we need to represent all of the values less than or equal to 9. So let's start with a number line here, and we'll put 9 right here in the middle, and then a couple of numbers on both sides. So we have 7, 8, 9, 10, 11. So here, G is less than or equal to 9. 9 is included, so we need a closed circle at 9. Now we need to represent the less than part. So we need all the values less than 9. So we need an arrow going left towards all of the values less than 9. And that's our graph. That represents G is less than or equal to 9. The filled circle shows that we are including 9. 9 is a solution. It will make the inequality true. And then the arrow shows all of the values less than 9. Now, one last thing we can do here is check a solution to make sure we are correct, make sure it works. So we need any value less than or equal to 9. Let's try 8. So we need to plug in 8 for G. So 8 minus 7 is less than or equal to 2. 8 minus 7 gives us 1. 1 is less than or equal to 2, so we are correct here. And let's actually check 9 as well to make sure that works, since G can be equal to 9, and we will do this mentally. So plug in 9 for G. 9 minus 7 gives us 2. And 2 is less than or equal to 2. So 9 works as well. Our answer, G, is less than or equal to 9. So G can be anything less than or equal to 9. Let's move on to number 2, where we have negative 15 is greater than y minus 11. So we need to solve this. We need to isolate y. We are subtracting 11, so we need the inverse operation of subtraction. That's addition. So add 11 to the right side. That means we need to add 11 to the left side as well. Now, as far as the right side, these 11s cancel each other out. So y is now isolated. We have y is less than, and then on the left side, negative 15 plus 11 gives us negative 4. So y is less than negative 4. So any value less than negative 4 is a solution of this inequality. It makes the inequality true. Now, one thing we can do here, we can rewrite this with the variable coming first. It makes it a little easier to work with, and all we need to do is flip it. So we have y, put the variable first, and then the inequality symbol needs to stay open towards negative 4. Y needs to remain less than negative 4. So be careful with the symbol whenever you rewrite an inequality with the variable coming first. So this is correct as well. Y is less than negative 4. Either of those work, so something to keep in mind. Now we're ready to graph. So let's start with a number line. And we have negative 4. And then we can put a couple of numbers on both sides. So we have negative 6, negative 5, negative 4, negative 3, negative 2. So y is less than negative 4. We are not including negative 4. Negative 4 is not a solution here. So we need an open circle at negative 4. Now y is less than negative 4, so we need all of the values less than negative 4. So our arrow is going to go left towards all of the values less than negative 4. And that's our graph. Now let's check a solution by plugging it into the original inequality and seeing if it works. So we need any value less than negative 4. Let's use negative 5. So we have negative 15 is greater than, and then plug in negative 5 for y, so negative 5 minus 11. Negative 5 minus 11 gives us negative 16. So negative 15 is greater than negative 16, so that works. We are correct. Y is less than negative 4. That's our answer. So any value less than negative 4 is a solution. It will work as far as this inequality goes. So there's our subtraction examples. Let's move on to multiplication. Here are our multiplication examples. Let's jump into number 1, where we have 5y is less than 40. 5 times y is less than 40. So we are multiplying y by 5. We need the inverse operation of multiplication. That's division. So let's divide the left side of the inequality by 5. That means we need to divide the right side as well. Whatever we do to one side of an inequality, we must do to the other in order to keep it balanced. Now on the left side, these 5s cancel each other out. Y is now isolated. So we have y is less than, and then on the right side, 40 divided by 5 gives us 8. So y is less than 8. And that's our answer. So any value less than 8 is a solution of this inequality. It will make it true. Now we can graph y is less than 8. So we are graphing all of the solutions here. Let's start with a number line, and we can put 8 in the middle. Then a couple of numbers on both sides. So we have 6, 7, 8, 9, 10. Now remember, when it comes to graphing inequalities, a filled circle shows that we are including that number, and then an open circle shows that we are not including that number. So here, y is less than 8. 8 is not included, so we need an open circle at 8. And now we need to represent all of the values less than 8. So let's draw an arrow going left, the direction of everything less than 8. And that's our graph. The open circle at 8 shows that 8 is not included, and then the arrow going left represents all of the values less than 8. And one last thing we can do here is check a solution. So we can plug in anything less than 8 for y and see if it works. Let's use 6. So plug in 6 for y. So 5 times 6 is less than 40. 5 times 6 gives us 30. 30 is less than 40, so we are correct here. Our answer, y, is less than 8. So y can be anything less than 8, and it will work. Let's move on to number 2, where we have negative 33 is greater than or equal to negative 11m. So we need to undo that multiplication. Let's divide the right side by negative 11. That means we need to divide the left side by negative 11 as well. Now remember, when we multiply or divide both sides of an inequality by a negative, the inequality symbol flips. It changes direction. So as far as the right side, these negative 11s cancel each other out. M is now isolated. The inequality symbol flips. And then on the left side, negative 33 divided by negative 11 gives us 3. So m is greater than or equal to 3. Now, as far as flipping the inequality symbol, that symbol flips as soon as both sides are divided by negative 11. Basically, it flips in order to keep the inequality true. I go into more detail about this in other videos. Those links are in the description. For this video, we will focus on solving and graphing. Now, as far as our answer, we have m is greater than or equal to 3. So m can be anything greater than or equal to 3. Now, we can rewrite this inequality with the variable coming first. So we have m, and then m is greater than or equal to 3. So that symbol needs to open up towards m. M needs to remain greater than or equal to 3. So again, keep in mind we can rewrite an inequality with the variable first if we prefer. Either way works. Now let's graph. So we can draw our number line here and put 3 in the middle with a couple of numbers on both sides. So we have 1, 2, 3, 4, 5. Now m is greater than or equal to 3. So 3 is included. It is a solution. So we need a filled circle at 3. Now we need to represent the greater than part. So we can draw an arrow going right, the direction of everything greater than 3. And that's our graph. The filled circle shows that we are including 3, and then the arrow to the right represents all of the values greater than 3. And then lastly, let's check a solution just to make sure we are correct here. So we can plug in anything greater than or equal to 3 for m in order to see if it works. Let's use 4. So we have negative 33 is greater than or equal to negative 11 times 4. Negative 11 times 4 gives us negative 44. So we have negative 33 is greater than or equal to negative 44. That is true, so we are correct here. M is greater than or equal to 3. And let's actually check 3 as well to make sure that works, since m can be equal to 3. And we will do this mentally. So plug in 3 for m. Negative 11 times 3 gives us negative 33. And reading the inequality from left to right, negative 33 is greater than or equal to negative 33. So that is true, 3 works as well. So there are our multiplication examples. Let's move on to division. Here are our division examples. Let's jump into number 1, where we have x divided by 4 is less than or equal to 12. Since x is being divided by 4, we need the inverse operation of division. That's multiplication. So let's multiply the left side of the inequality by 4. Whatever we do to one side of an inequality, we must do to the other. So multiply the right side by 4 as well. Now on the left, these 4's cancel each other out. X is now isolated. So we have x is less than or equal to. And then on the right side, 12 times 4 gives us 48. So x is less than or equal to 48. That's our answer. So any value less than or equal to 48 is a solution of this inequality. It will make it true. And now we're ready to graph this. So we can start with a number line, and we will put 48 in the middle, and then a couple of numbers on both sides. So we have 46, 47, 48, 49, 50. So we need a filled circle at 48. And now we need to represent the less than part. So we need an arrow going left towards everything less than 48. So the filled circle at 48 shows that 48 is included. It is a solution. And then the arrow going left represents all of the values less than 48. So that's our graph. And one last thing we can do here is check a solution to make sure we are correct. So we need anything less than or equal to 48. Let's use 40 since we are dividing, and that will work nicely with the 4. So we have 40 divided by 4 is less than or equal to 12. 40 divided by 4 gives us 10. And 10 is less than or equal to 12, so we are correct here. And let's actually check 48 as well to make sure that works, since x can be equal to 48. Now we're going to do this mentally. So we have 48 divided by 4 is less than or equal to 12. 48 divided by 4 is 12, and 12 is less than or equal to 12. So 48 works as well. Let's move on to number 2, where we have w divided by negative 9 is less than 7. So we need to undo the division here. Let's multiply the left side by negative 9. That means we need to multiply the right side by negative 9 as well. Now remember, when we multiply or divide both sides of an inequality by a negative, the inequality symbol flips. It changes direction. So on the left, these negative 9's cancel each other out. W is now isolated. Then the inequality symbol flips. And then on the right, 7 times negative 9 gives us negative 63. So W is greater than negative 63. That's our answer. So W can be anything greater than negative 63. Now, as far as flipping the inequality symbol, that symbol flips as soon as both sides are multiplied by negative 9. Basically, it flips in order to keep the inequality true. So as far as our answer, W is greater than negative 63, we are ready to graph. So let's draw a number line with negative 63 in the middle, and then we can put a couple of numbers on both sides. So we have negative 65, negative 64, negative 63, negative 62, negative 61. W is greater than negative 63. So negative 63 is not included. It's not a solution. So we need an open circle at negative 63. Then we need to represent the greater than part. So we need an arrow going right towards everything greater than negative 63. The open circle shows that negative 63 is not included, and then the arrow going right represents all of the values greater than negative 63. And that's our graph. And lastly, let's wrap this up by checking a solution. So we can use anything greater than negative 63. Let's use negative 54 and plug that in for W. That will work nicely with that negative 9 there since we are dividing. So negative 54 divided by negative 9 is less than 7. Negative 54 divided by negative 9 gives us 6. 6 is less than 7, so we are correct here. Our answer, W, is greater than negative 63. So there you have it. There's how to solve and graph inequalities. I hope that helped. Thanks so much for watching. Until next time, peace.